Hello and good day to you. You're once again welcome to MESO Constructions, where we discuss all things engineering, architecture, and 3D modeling. Today, we'll be learning in Protastructure how to design a strip foundation. However, a strip foundation can be reinforced and can be unreinforced. For the case of an unreinforced strip foundation, where it's usually done in combination with other forms of foundation such as pad foundation, which is very common where I come from, as we incorporate a layer of concrete in our pad foundation on the surfaces that will be laying the masonry work in order to give the foundation masonry work a very solid ground to stand upon. And then we have our pad footings excavated way deeper than the layer of our strip, and in this case the strip foundation is not usually reinforced. Nevertheless, in this tutorial for today we'll be learning how to design a strictly reinforced strip foundation. Before further ado, we encourage you to subscribe to our channel for more contents like this, and also don't forget to turn on your notification bell to be the first to see our latest tutorial videos from Protastructure and civil engineering. Thank you. Now let's get right into the video. Now we have this structure here, this demo structure, a model of a building with just one floor, and as you can see it's painted yellow because you have here that the analysis is expired, and in order for you to design your foundation, any kind of foundation, not just strip foundation this time around, you need your building analysis to be properly done and your structural members to be properly decomposed, that you have all the loads from the slab decomposed to the beams, decomposed to the columns, and then decomposed to the floor that is supporting the floor on which the building will be erected. And for now we have these foundation springs right here acting as a pseudo foundation for this structure. So what we just want to do is we want to see how this structure will behave if we install a strip foundation in place of these foundation pins. So let's get right into it, and we do that by going to perform a building analysis on this. And to perform a building analysis on any structure, what you need to do first is to do your load quizzes, your load combination, the loads that you want to be acting on your structure. You have to get that right. We have the dead and life load here, then the dead and life load and the notional load along the x-axis. Now I'm just going to work with this. So when you want to look at it in loading generator, you can see that we have this. I don't want pattern loadings here, and yeah, I can go right here to click on steel and concrete, and then I go to horizontal. What I just need for the horizontal is notional, so I don't want to use cracked sections. So I'm just going to press OK right now, and then you see this is generated. I'm not applying PDF analysis, and I can press OK. Then I have my load generated. Then I can also go on to decompose loads, and when I go here you see that I've already decomposed loads and my load decomposition initially still works. So I press OK, and then I go from there. It's loading, it's doing the work. I can wait a little bit, and then I press OK. Then I close this and apply to all beams in the model. Here now I can go on to do my building analysis. But before I do my building analysis, I want to check on my rebar diameters, and I think they're okay. I'm using 16 for the columns. I'm using 12 for the walls. That's shear walls, concrete walls, like shear walls. Then the latinar web, I'm using 12 for this as well, even though I don't have any in this drawing. Horizontal, I'm using 12, I don't have any. Then the concrete beams, I'm using 16. And then I think we can just simply run through this building analysis, because we've already touched building analysis in our previous lessons, and I don't think there's any necessity for us to waste more time dwelling on how to perform our building analysis. And I think we can just quickly just run through that. Now you have my Asia load comparison report and my building analysis, and you can see my deflection looks okay, and my displacement rather looks okay, and when I plate it also looks good. And from here we can go back to our model, and then you can see that the design status is okay. And from here we can go back to our story zero in order to design our strip foundation. And as you can see, we have our slab and beams available for installation in our foundation. However, we are going to be installing beams, and I want my beam to be 50 by 300 mm for the width and the depth. Then we can go on to start drawing our beams over each column until we have all columns connected to our foundation beams. The next step now is to insert strips, and we can do that by clicking the insert strip at the top or using our right mouse button then navigating to insert strip footings. Once you insert strip footings, this panel pops up and you can go through all our parameters for the beams. However, I want my LHS and RHS cantilevers to be set to 450 mm, and this is exactly what it means. The part of the beam projecting beyond the column is set to 450 mm. I will be leaving my fitting width as default 1000, but if you'd like to adjust my fitting depth to 300, then we can go on to design the strip fitting. We have the shear force and bend moment diagrams illustrated as follows. I can then press OK and OK again to design my strip footing. And when we return to our story zero plan, you can see that we have our strip footings generated around our beams. Now we need to design our beams, but I'd like to adjust the size of my beams by making the width to be 300 mm and the depth to be 450 mm. In most cases, designs like this should follow the consultations of soil test reports, but we are only taking liberty of assuming values for the purpose of this tutorial. Now I think our strip footing looks a lot better and more symmetrical too. Then we can go ahead to design our beams as shown. After designing our beams, we can see in our 3D that our design status confirmed that our beams have been designed and marked OK as well. This is it for now on our tutorial on how to design strip foundation in Protastructure. Don't forget to subscribe to our channel for more contents like this on how to use Protastructure for structural engineering and all things related to construction. Turn on your notification bell to be the first to see our latest tutorial videos on Protastructure and all things related to construction and architecture. Thanks for watching, and bye for now.